Grade 11s, welcome to Leonard and Acid. Today we are going to be taking a closer look at the laws of exponents, and this topic is examined in question 1 both in grade 11 and 12, and it features a lot in calculus where you have to simplify some equations using the laws of exponents. So today I am going to be taking you through the basics of exponents. Now, what is an exponent? An exponent is anything that can be written in the form of a to the power of n, where a is the base of an exponent, and then n can either be called an index, exponent, or a power. Okay, now what is the meaning of a to the power of n? What does it mean to have an expression like this? Well, if you have a to the power of n, then that means that a will be multiplied by a how many times? N times. So this will be a multiplied by a multiplied by a multiplied by a, going on to the last term, which will be a, and this gets repeated n times. Okay, for example, if I give you 4 to the power of 4, what's the meaning of this? It means that whenever, or rather it means that 4 will be multiplied by 4 how many times? 4 times. So this will be 4 times 4 times 4 times 4. So this gets repeated 4 times. Let's take a closer look at another example. If I give you 5 to the power of 6, what's the meaning of this? It means that 5 will be multiplied by 5 how many times? 6 times. So it'll be 5 times 5 times 5 times 5 times 5 times 5. So this will get repeated 6 times. So that's the meaning of 5 to the power of 6. Now, there are certain rules of exponents that you need to know off by heart in order to simplify expressions, and these are the rules as you can see them right here. The first rule says that whenever you multiply the powers of the same base, you have to add the exponents. Okay, for example, if you have 2 to the power of 4 times 2 to the power of 2, that will give you 2 to the power of 6. So you are multiplying the powers of the same base. So when you multiply the powers of the same base, you have to add the exponents to remain with 2 to the power of 6 then. So that's how rule number 1 works. And then the second rule says that whenever you divide the powers of the same base, you have to subtract the exponents. So if you have 2 to the power of 4 divided by 2 to the power of 2, that will be 2 to the power of 4 subtract 2, giving you 2 to the power of 2. So that's how the second rule works, and it can also be reversed as well, so you need to take note of that. And then the third rule is as follows: if you have maybe like two numbers that are multiplied together within a bracket, and then that bracket is raised to an exponent, that exponent can actually be distributed among these numbers which are multiplied together within a bracket. So it will be a to the power of n multiplied by b to the power of n. Let's have an example to see how this works. I'm just going to erase here so that we can have space. Yeah, so if you have let's say for example you have 2x and then this expression is raised to the power of 2. Now, in order for you to simplify this using this rule, this can be written as 2 to the power of 2 times x to the power of 2. Now, what is 2 to the power of 2? That is 4, and then you remain with x squared, so it will be 4x squared. So this is how rule number 3 works. And then the fourth rule says that if you have a fraction that is enclosed by brackets then raised to an exponent, then that exponent can further be distributed among the numerator and the denominator. So if you simplify this, it will be a to the power of n, b to the power of n. Let's have a look at an example to see how this will work. Let me just erase here so that we can get enough space for writing. So if you have for example, let's say maybe you have 3 over 2, or let's say 2 over 3 all over 2, then this can be simplified to 2 to the power of 2 all over 3 to the power of 2, giving you 4 over 9. Okay, so this is how you can actually use the fourth law of exponents. And then the last one says that whenever you have maybe like an exponent, okay, an exponent that is raised to another exponent, what you have to do in that situation is you'll have to multiply the exponents. Okay, so this bracket here will act as a multiplication sign for the exponents. So this will be a to the power of n multiplied by n. So that will be let me check, maybe if you have 2 to the power of 2, then that is raised to the power of 2, then you can simplify it as 2, and then what is 2 multiplied by 2? That is 4. Okay, so that's how you can use the laws of exponents to simplify expressions and work with equations that require you to apply the laws of exponents there. Now, another thing that you need to take note of is that a and b, which are the bases of the exponents, they have to be greater than 0. They shouldn't be 0, because if they become 0, then that thing will be undefined. Okay, so a and b, they have to be greater than 0. As you can see here, that a and b here, b they are actually the basis of the exponent, and so the base of an exponent can never be 0, so it has to be greater than 0. And m and n, they have to be the element of integers, meaning that they can be anything positive or negative. They can also be 0 sometimes. Okay, so they can be anything. So that's the meaning of the statement here below. So that's it for this lesson. And then on the next lesson, we are going to be looking at the examples, trying to figure how we can work with the laws of exponents. Okay, and then another thing that I want to emphasize just before I conclude this lesson is that if you have something like a, if you have a to the power of -1, this can be written as 1 over a to the power of 1 there, so that can be 1. So when you work with the laws of exponents, or when you work with exponents, you are not allowed to leave them as negative answers. They should always be positive exponents. Okay, so your final answer can never be a to the exponent negative 1. It has to be a to the exponent positive number or anything there, but it has to be a positive exponent. So that's another thing that you need to bear in mind when you are working with the exponent. So yeah, that's it.